Welcome viewers, I welcome you all to our YouTube channel Mathsdiscussion.com.
In this video, we are going to look into the polynomial expressions. Now, not only the polynomial expression, zeros of the polynomial expression and the relation between the coefficients and the zeros of the polynomial expressions.
Do not forget to subscribe to our channel. Not only subscribe it, also like it and share it to your friends so that they also get the benefit of the Mathsdiscussion.com. And most important thing, do select the bell icon so that whenever we upload any new video on similar content on mathematics, you will be getting the immediate notification for that. Now in the polynomial chapter, first of all let us see what we mean by the polynomials. Basically the expression which are of the form an x power n plus an minus 1 x power n minus 1 plus an minus 2 x power n minus 2 and so on till a0, where a0, a1, a2, a3 so on till an all are real numbers, and this expression is called as a polynomial of degree n if my an is not equal to 0 for any natural number n. Now once you understood what is the polynomial equation, now there are different types of polynomial equations. We say a linear polynomial equation where the degree is 1, like fx is equal to 3x plus 2. A quadratic polynomial equation where the degree is 2, for example fx is equal to x square minus 2x plus 3. Then a cubic polynomial equation where the degree is 3, for example minus 3x cube plus 2x square minus 3x. So these are the different types of the polynomial equations. Now, once we have seen what is the polynomial equations, now let us discuss about what are the zeros of the polynomial. Let us say you have a quadratic polynomial equation fx is equal to x square plus x minus 2. Now in this you can check up, if I put the different values of x, we get the different values of fx. For example, let us say if I put x is equal to 0, the value of the polynomial will be f of 0 is minus 2. Similarly, if I put x is equal to 2, we get f of 2 is equal to 4 plus 2 minus 2, that is 4. And for x is equal to 1, fx turn out to be nothing but equal to 1 plus 1 minus 2, that is 0. So likewise you can see that as we put different values of x, we get the different values of fx. But here one thing you can notice, that is once I put x is equal to 1, my fx has become 0. And once you put x is equal to 0, it is minus 2. When x is equal to 2, it is 4. Now in particular that value of x corresponding to which fx has become 0 is what is called as the zeros of the polynomial. So like in the given illustration, that value will be nothing but x is equal to 1. Remember that x is equal to 1 is one of that value. So what does it mean is, that means if my f of alpha is 0, then alpha is a 0 of the polynomial. Now if I have an n degree polynomial, then there exist at most n different real zeros. Remember that, at most n different real zeros. Now let us look into the relation between the zeros and the coefficients of the quadratic polynomial. Let us say fx is equal to ax square plus bx plus c is a quadratic polynomial where a is not equal to 0 and a, b, c are real, and has the zeros of this polynomial are alpha and beta. Then the relation between the zeros and the coefficients are, the sum of zeros is nothing but equal to alpha plus beta is minus b by a, that is minus of coefficient of x upon coefficient of x square, and product of zeros is alpha into beta is c by a, that is constant term upon the coefficient of x square. This is the relation between what we have is the zeros of the polynomial and the coefficients. Now using the same relation, we can form the equation given the zeros of the polynomial. Let us say alpha and beta are the zeros of some quadratic polynomial. Then the quadratic polynomial will be given by fx is equal to some constant k into x square minus sum of zeros into x plus product of zeros. That means x is equal to k equal to x square minus alpha plus beta into x plus alpha into beta. So that is the relation between the coefficients and the zeros of the quadratic polynomial. Now next let us see the relation between the zeros and the coefficients of the cubic polynomial. Once again let us say fx is ax cube plus bx square plus cx plus d, where a is not equal to 0 and a, b, c, d all are real. Be a cubic polynomial with alpha, beta, gamma as its zeros. Then the relation between the zeros and the coefficients are sum of zeros, that is alpha plus beta plus gamma, will be minus of b by a, that is minus of the coefficient of x square upon coefficient of x cube. Then sum of product of zeros taken two at a time, that is alpha beta plus beta gamma plus gamma alpha, is c by a, which is equal to coefficient of x upon coefficient of x cube, and product of zeros is alpha beta gamma, that is minus d by a, which is minus the constant term upon coefficient of x cube. So this is the relation that exists between the coefficients and the zeros of the cubic polynomial. Now, given the zeros of the cubic polynomial alpha, beta and gamma are the zeros of the cubic polynomial, how we can formulate the cubic polynomial? Let us say fx is the cubic polynomial, then fx is given by some arbitrary constant k into x cube minus sum of zeros into x square plus sum of product of zeros taken two at a time into x minus the product of zeros, that is k into x cube minus of alpha plus beta plus gamma into x square plus alpha beta, beta gamma plus gamma alpha into x minus alpha into beta into gamma. So this is how we can formulate the cubic polynomial given the zeros of the polynomial. And finally, how do you find our video? Do write in the comment box what you liked or what you did not like into the video. And one of the biggest advantage of Mathsdiscussion.com is we also have a website in which we have got a discussion forum. You can register into our website. The website address is www.mathsdiscussion.com. There you register yourself with your email ID and create your user. Whatever you want to ask either on this topic or any other topic of your interest, you can put a question into that and discuss whatever the doubts you got. And don't forget to write your comments into the comment box so that we'll give a reply on to that. And anything new what you want in these videos, do write it to the comment box so that we try to incorporate that into our future. And once again, I request all of you to subscribe to our channel and share it with your friends so that they also get the benefit of mathsdiscussion.com. And thank you.